to Tran. I am a clinical pharmacy manager for Long Beach Memorial Medical Center in Long Beach, California. Today, I will be presenting to you on USP 797 and sterile compounding here in the United States. So we follow a regulatory requirement called USP, so United States Pharmacopoeia, and the mission of the USP is to basically improve global health through standards to ensure quality, safety of both medications and foods. So for our state here in California in the United States, it is considered a best practice guideline, and it's not considered a law unless it's enforceable by our Board of Pharmacy, which here in California it is. So the United States Pharmacopoeia sets various standards, based off of the Food and Drug Cosmetic Acts here, and it is enacted into law by our Board of Pharmacy. It's enforced by all of our regulating bodies here. So in the United States, we have our hospitals are very regulated. So we have various boards of pharmacy. We have the Joint Commission. We have the Centers for Medicaid and Medicare Services, the Department of Health, all trying to regulate the practice of pharmacy in the state of California. So in terms of what is enforceable and what is not, USP 797 is the focus today, which is the sterile compounding piece of the best practice guidelines in USP. So just to have everyone understand, USP is a very long and arduous best practice guideline. So anything over the number 1,000 is only informational. Anything less than 1,000 is considered enforceable by law. So the minimum required standards versus the recommended best practice is designated in the guideline. So the word shall or must will designate that it is required by the best practice guideline. Should means that it is a recommendation. And we'll go over kind of what the requirements are. So in terms of compounding, there's our 4 main USP best practice standards. USP 795 that covers non-sterile compounding, USP 797 that covers sterile compounding, USP 800 that covers hazardous drugs compliance, and then USP 825 that covers radiopharmaceutical compounding. So for the purpose of the compounding standards, we are going to be looking at USP 795, 797 with the focus of 797 on this particular lecture. So USP 797 is basically the sterile compounding standard. For us here in the United States, it was last revised in 2008. It has a current revision that is under appeals that was published in 2019. And right now we are awaiting the final publication of what it was appealed in 2019. Today is September 2022, and we're still waiting on the best practice standard. So some of the items that are covered in USP 797 that we'll touch base, very briefly on this lecture is what is the ISO classification, definitions, what is the responsibility of the compounding personnel, microbial level contamination risk levels, personnel training and evaluation of aseptic technique, personnel cleansing and garbing, verification of compounding accuracy and sterility, environmental control, testing, cleaning, and beyond use dating. So we'll cover each of those subsets of levels and kind of go over our sterile compounding requirements here in the state of California. So ISO classifications depends on basically what they're looking at to check the particles in the air, right? So the laminar flow hoods that we use here are considered ISO 5 classification is one of the cleanest classifications in our sterile compounding room. It is so all the laminar flow hoods as well as our biosafety cabinets basically for the ISO 5 classification is they should have less than 3,520 particles using a 0.5 micron filter. The room itself is also ISO classified, so we make sure that our rooms are clean as well with HEPA filters in our ceilings. It should be classified as ISO 7, which is considered the secondary engineering control where the hoods are located in. So some commonly used terminology is the anteroom. So the anteroom is the room where the individual goes into gown and garb before they go into the buffer room where the hoods are located. So that should be ISO 7 or better air in that room in the state of California. And then the reason why that's important is because the beyond use dating of a sterile compounding product is determined by where you make the sterile compounding product. So if you make a sterile compounding product on a table outside of the sterile compounding lab, it will have a different beyond use dating rather than making it in a sterile compounding lab inside a sterile compounding hood. So to give you a better representation, I'll show you kind of a diagram of what our clean room looks like, and then we'll show you a video at the end of what our actual clean room is. So as you can see in the middle area, the ISO 7 anteroom is where the individuals go in gown and garb and wash their hands. So they'll need to wash their, put on their foot coverings, put on their hairnet, and then put on their gowns, wash their hands, and then go into either the non-hazardous buffer room or the hazardous buffer room. These two rooms are where the actual sterile compounding occurs, and inside an ISO 5 laminar flow hood or a biosafety cabinet is where it occurs. So some common terminology that is used is first air in the clean room. So it's the air exiting the HEPA filter that is particle free. So it's the cleanest air in the entire clean room. So our multi-dose vials here, so vials of potassium chloride that we have that has some preservatives, we give it a 28 days beyond use dating. And any single dose vials that we open in the clean room or in an ISO 5 environment, the hood, we give it a 6-hour beyond use dating. So what that means is that that product needs to be used within 6 hours of opening and first puncture of the vial. So other terminologies that we use here in the United States is called a segregated compounding area. So in a smaller hospital that doesn't have a compounding lab, there is a separate area in the pharmacy where there is a ISO 5 laminar flow hood that they can make sterile compounding products. This area basically can be used to make sterile compounding products, but gets a very short beyond use dating because it's not in a sterile compounding lab. So some common terminology that that is different is the differences between expiration dating and beyond use dating. So expiration dating, the definition of an expiration date is the date that the product can no longer be used at all. It is usually assigned by the drug manufacturer, and it usually applies to manufactured products, APIs, or excipients, versus beyond use dating basically means the date and time that a compounding product should not be administered or began being administered. So what that means is that as long as the product is given to the patient before the beyond use dating, it can complete its entire infusion time. So the differences between expiration dating and beyond use dating. And traditionally here in the United States, we use the term beyond use dating to be used for all compounded sterile products. So it takes into account both not only the stability of the ingredient, but as well as the sterility of the ingredient. We'll talk about how we determine stability and sterility at the later slides. So here is a brief example of what is the differences between beyond use dating, hang time, stability, and expiration. So in terms of beyond use dating, it's the time between when you start making the sterile product and when the administration begins. The hang time is defined as when the administration starts, when the administration ends. The stability of the product is determined by what the manufacturer determines as what the product is stable in. And then the expiration dating of the product is determined by the actual ingredient expiration of when we can no longer use any of the starting ingredients. So in the state of California and the United States now, there's 3 risk levels of compounding, right? So we'll go over those risk levels and tell you kind of what we're doing here in the state of California. So the first risk level is the low risk. So basically everything is made in a laminar flow hood, only sterile ingredients or products, and requires less than 3 ingredients and no more than 2 entries into a product. So an example is an antibiotic that you have to reconstitute, like Ansef. So you have a 1 gram Ansef and you're reconstituting it with sterile water, and then you're taking that entire contents and putting it in a dextrose 50 ml saline or a dextrose bag, 50 ml bag, and that is considered low risk. So by doing a low risk compounding, you can assign a beyond use dating of 48 hours at room temperature or 14 days in the refrigerator. Versus compounding it in a segregated compounding area, like I stated earlier, in just a regular pharmacy without any ISO classification in the pharmacy, you can compound a low risk compounding as long as it's in an ISO 5 laminar flow hood. You get a maximum beyond use dating of 12 hours. So you see the differences between making it in a compounding lab versus making it in a segregated compounding area. The second and most common products that we make here in the United States is medium risk compounding. So this is like batch compounding. We're making multiple individual small doses of compounded products for multiple patients. So a big example that we do here is vancomycin. So we take a 10 gram vancomycin vial, reconstitute it with sterile water to make 10 1 gram vancomycin doses in NS250. So these are complex aseptic manipulations that takes a longer time in a laminar flow hood. So it's multiple ingredients aliquoted into smaller doses, and that will allow only for a shorter beyond use dating time. That gives us a 30-hour room temperature beyond use dating or a 9-day in the refrigerator. High risk compounding is something that we do not do here at my facility, but basically it's taking a non-sterile ingredient like an API and converting it into a sterile product. We won't go over this quite a bit because I don't have experience in this, but basically this is taking like a bulk API, making it into a sterile product by a sterilization product, and as you can see, it gets a even shorter beyond use dating. So as you see, the more complex the sterile compounding gets, the less beyond use dating you get and the shorter amount of time you have to use it. So we can talk about immediate use. So we have a small carve out here in the United States and in my facility for an immediate use. So in a certain code situations where a patient, is doing CPR and they need like a drip of dopamine or norepinephrine, so we can make that at the bedside, and with medications that we bring from the pharmacy because the patient needs it right away, and that gets a beyond use dating of 1 hour. So that means that the product needs to be hung on the patient within 1 hour. And what the pharmacy then does is it then goes to the compounding lab, makes a second bag, and then we then go ahead and switch that bag out for that patient to make sure it maintains its sterility. So we talked about single dose and multi-dose containers already. So there's different types of containers that we have here in the United States. Single dose is the most common one where most individual products like the IV bags and vials are. So the single dose containers, if open in a laminar flow hood, gets a 6-hour beyond use dating versus if it's not opened in a laminar flow hood, it gets only 1 hour beyond use dating. So here are some photos of our compounding lab. So as you can see here, we have our laminar flow hoods to the right. We have all of our medications located right next to our pharmacy technician. We have our label printers that prints the labels for any patient-specific doses. And then we have, on the left photo here, we have our pharmacist who's inside the clean room checking IV products on a computer. Every single laminar flow hood that we have has a workstation that has a computer that allows for barcode scanning. So every single product that we make, we require our technicians to barcode scan not only the individual ingredients, but we have to input the lot number and expiration dating to ensure that, we capture any recalls or anything, any quality assurance problems that we have in the later slides. So, and we have also refrigerators, in our sterile compounding lab. But we make anywhere between 1,000 to 3,000 products a day at our facility. So it is a very fast-paced and a very busy work environment. And then, so this is more just additional photos. As you can see, this is the pharmacist workstation in the middle with a barcode scanner. So the pharmacist utilize the barcode scanner to check the individual compounded sterile products in our clean room. We have a process called a pre-check workflow here. So what that means is that any product that is made, a pharmacist needs to check the volume of the drug being pushed into the IV bag prior to the technician compounding. So that is a key that is different than any other facilities here in the United States, as we require all IV products, compounded products, to be pre-checked by a pharmacist. So I will go ahead and show the video of our clean room at the end, and I'll continue with my slides and talk about kind of our quality assurance program. So being able to work in a compounding lab here in California, we require a lot of training. So one of the things that we require all of our technicians to do is to review our standard operating procedures, our SOPs. We do annual media field testing, so testing of an individual to make an IV product. Annual finger glove tip testing, so making sure that the individual knows how to gown and glove appropriately. And then making sure that we observe them how to gown and garb and how to make a sterile compounded IV product appropriately. All these happens on an annual basis with an employee who requires sterile compounding competency, and a manager or supervisor is the one that is observing them on an annual basis. So part of our annual quality assurance program is to ensure that the actual room was built appropriately and that the facilities is being maintained, right? So we have a viable and non-viable environmental sampling that is required by law. So in terms of what is required, it is required to be done twice a year. And what that means is that we have to get an outside company to come in and test our room to make sure it is up to the standards of the Board of Pharmacy. So in terms of the viable air sampling, what are we doing is we're taking an air impact gun. We're testing our air to see if it grows any microbes. So what we do is we put a machine that sucks air into the machine. We have a agar plate that sits underneath the air impact gun, and then we test the air for anywhere between 10 to 20 minutes at various locations in our clean room. And we test anywhere between 20 to 30 locations to make sure there is no pathogenic bacteria in the clean room. We also test the work surfaces. So as you can see in the pictures of the clean room, there's a lot of different work surfaces. So we test a lot of different of those areas to make sure that they are free from microbial contamination. And all of this is done, the air is done every 6 months, but the surface is done every month. And we test both for bacteria and fungus in our clean room. Not only do we have to test for a viable sampling, which is the bacteria, but we have to test for particles. So it goes back to the ISO classifications, right? So we need to make sure that our clean room maintains the ISO classifications. So we have to send or have an outside company come into our clean room and test to make sure that there are no particles in our buffer rooms, there are no particles in our ante room, and there's no particles in our ISOFly, laminar flow hoods, or biosafety cabinets. Also, each room needs to maintain an appropriate pressure differential, right? So the positive pressure room versus a negative pressure room. And if you have questions about that, we can go into that at a more depth. But that is also required by our law here in California, that we test the pressure differentials for all three rooms to make sure there is determining a pressure gradient that is maintained. So here's a sample of our testing guide. So as you can see, it's a very all-inclusive, all-encompassing testing guide of all the areas we're testing in our compounding lab. As you can see here, for the surfaces, we're testing anywhere between 20 to 30 areas. And then in terms of the air, we're also testing an additional 20 to 30 areas as well. And here we go is our testing guide. So we follow this guide on a monthly, semi-annual, as well as an annual basis to test to make sure that we are meeting standards defined by our Board of Pharmacy. So in terms of, you may ask what happens if, there's some growth in our clean room, and we have to follow USP and what their standards. So in terms of viable action levels, the air action levels, you can see here in the ISO 5 environment, which is the hood, if we have more than one colony, that hood is out of commission and we cannot use, and we need to retest, reclean and retest. The room, ISO 7, as you can see, it has a breakpoint of 10. So we utilize this table as part of our policy to dictate what we do once we have a out of specification results. So for the surface sampling, if we in an ISO 5 environment, if you have more than 3 colonies in a agar plate, that is considered failing. In an ISO 7 environment, which is the actual buffer room, we will fail if it's greater than 5. So one of the important things to maintain a clean room, as well as our the quality assurance program to ensure that there's no growth in our clean room and particles, is our cleaning. So we have a very rigorous cleaning program here in our compounding lab. And we utilize, USP as kind of a guidance of how we clean. So for us here in the state of California and at my facility and compounding lab, we clean the floors and the countertops and the work surfaces of the laminar flow hoods on a daily basis. And then the laminar flow hoods are actually cleaned on a more routine basis after every shift, after every batch, so that it maintains its sterility. So in terms of a terminal cleaning, so it means that we clean from top to bottom in our compounding lab, including the ceilings, the wall, the floors. We clean that. We have what we call a triple clean. So we clean it with a germicidal, a sporocidal, and a sterilant, like sterile alcohol, on a weekly basis. So we do that once a week. During our hours of 2 a.m. to 5 a.m. to ensure that our compounding lab maintains its sterility. So having a proper and a good cleaning program is essential in order for your sterile compounding products to be sterile at the time of administration. And with that being said, I would like to share with you some of our policies. One in particular is our quality assurance policy here. So this is a policy that I've shared with Thuyen and Hafam, and so that we can share with your team. But this is what we follow in order to maintain a proper sterile compounding facility. And then it goes over certain procedures as requirements for all employees that works in the sterile compounding lab. It talks about pharmacist requirements and training. It talks about media fill testing and what is required for any staff members to practice in the sterile compounding lab, and what happens and how the SOPs and how we provide that test. And then what happens when there is a out of specification results. We talk about the finger glove testing to ensure proper gowning and gloving, and what we do in terms of procedures and how we incubate the plates, and what happens if there is a out of specification result. We talked about our environmental controls and how we build our clean room, and what we need to monitor on a daily basis, such as the temperature of the room, the humidity of the room, as well as the pressure differentials of the room and what the requirements are. And then we talk about our quality assurance program, including our surface sampling that we went over on a monthly basis, our air sampling, both viable and non-viable on a semi-annual basis, and our procedures and the equipment that we use for the viable air sampling and what we do when there's an out of specification result. And one thing I wanted to highlight also is that we do batch sterility testing of our actual products on a quarterly basis here, which is part of our quality assurance program. So for batch testing is every single quarter, every 3 months, what we do is we select 10 random samples from any technicians or pharmacists that makes products in our clean room, and we test them for sterility. We use a product called the QT Junior system here. What that product is just a media that we run the IV product through, and then we incubate that media for 2 weeks, and then we see if there's any bacterial growth. How we identify bacterial growth is very simple, is that if the solution gets cloudy in the incubator, you know that there is bacterial growth in there because it's a growth medium that we are running the IV products through. So this is the long SOP that we follow and how we test, and we test for it. And I've been working here in the sterile compounding lab and being the manager for about almost 10 years now, and we have never had an incidence where we had a sterile product that was suffered from sterility issues. So I'm happy for that here, because again, we have a very rigorous cleaning program and training program to maintain the actual clean room so that we avoid problems with the sterile products. So the other piece of testing a sterile product is not only to make sure it's sterile at the time of administration, but to make sure it's the right dose, concentration, and product that we say it is on the label. So we also do a quantitative analysis. So we send out 10 random samples every single quarter as well. And these 10 random samples are of medications such as antibiotics, pressors, norepinephrine, dopamine, nicardipine, anything that we make in our clean room, we send out to test to make sure it is potent. We do not do that testing here in our compounding lab or in our pharmacy. We actually send it out to an outsourced lab in the state of Missouri. And the turnaround time for this is anywhere between 3 to 4 weeks to test for the actual ingredient and potency in the actual product. We have had times where we send it out and the product comes back, lower potency than expected. And then we have a SOP here that we follow to ensure that, we have our directors notified, as well as our senior leadership here is notified of any issues regarding our quality assurance program. And I will share this with you, and in terms of more policies and procedures that we follow, including beyond use dating. And let me share with you our video here as well of our sterile compounding lab, and then I will be available for any questions that you may have. So as you can see here, the technician is scanning every single product with the label to ensure that they are having the right ingredients. And she is utilizing the computer in the back as a validation. And after the technician compounds, the pharmacist does the exact same thing. They log into our electric medical record system. and they are checking the product at the time of compounding and ensuring that the correct product was made and before sending it out to the patient. The pharmacist is also required to physically sign the actual bag as well to ensure that we know who actually checked it and that pharmacist checked it when it leaves the. Here is our hazardous compounding area. So as you can see, it's a little bit different, color-coded a little bit differently, all in yellow bins, which designate that it is a hazardous compounding area. So these are biosafety cabinets with the same setup as our any laminar flow hoods with the computer workstations for barcode scanning as well. And now I leave it up for any questions that you may have.